Okay, class, this is section 2.7, number T18. We have a cubic function, h of x is equal to x cubed, and we need to just show that the cube root of 7 is a real number, and it's going to be somewhere between 1 and 2. So we're going to use the intermediate value theorem to do this. The first thing that we do is make sure that we state that h of x equals x cubed is a continuous function. I know that this is a cubic function, it's continuous for all real numbers x, so it is also continuous on this closed interval between x is 1 and x is 2. I know that h of 1 is equal to 1 and h of 2 is equal to 8. I also know that in terms of those y values, those are dependent values, that 7 is certainly between 1 and 8. Therefore, there has to be some real number x that is between 1 and 2, right? Between x is 1 and x is 2, such that 7 is equal to x cubed. Now specifically it is cube root of 7, but we're saying that we can approximate that value and it's somewhere between 1 and 2. I don't know exactly what decimal approximation it is, but I know it's between 1 and 2. So it's got to be on that open interval. It's all the result of the intermediate value theorem. You see here we have a continuous function. We have the closed interval a to b, so in this case it's 1 to 2. And we know that there's some y value, in this case we picked 7, that's between 1 and 8. So there's got to be some value, and following that rule, 7 has got to be equal to x cubed. The intermediate value theorem doesn't tell you what the answer is, it just tells you that it's in there somewhere. So we know that the cube root of 7 is somewhere between 1 and 2, and it has to exist. So that's the intermediate value theorem, go IVT. This is a near certain test question, so make sure you're ready for this kind of problem on Tuesday when we take the test.